I heard that your company was in the steel business. Is your newly developed product somewhere in this toilet?
First of all, I want you to see if you can smell that distinct toilet odor.
No, it doesn't smell at all. There's usually an unpleasant odor.
The secret lies in the floor under your feet.
Here is the product that the Takumi developed. These tiles contain a photocatalyst that reacts to light. I took a reading of the toilet's odor level. The meter read 52. This is roughly half the amount found in public toilets. The photocatalyst effectively assisted in decomposing the odor.
This is the material.
It's so soft and very light. The identity of the photocatalyst is this titanium oxide powder. When the titanium oxide comes into contact with light, it reacts to the oxygen and water in the air and produces active oxygen. It's this active oxygen that decomposes odor sources like ammonia. On top of that, it also kills E. coli bacteria and influenza viruses. How did a company in the steel industry get involved in the development of antibacterial products?
I didn't feel that there was any more room in the steel and iron industry to grow in Japan. I felt that the environmental business was promising and wanted to break into it to help boost the company's performance as a whole.
But the development of the tiles involved much trial and error. To fix the photocatalyst agent onto the tiles, they first tried mixing it with glue. However, this method reduced the density of the agent and did not perform as well. It also peeled off easily. So the Takumi set its sights on thermal spraying, which is widely used in steel factories. In thermal spraying, the coating agent is melted and then blown onto metal or other surfaces at a high speed. But the technique could not be used without making changes. This is because heating the photocatalyst to 2000 degrees would cause it to lose its photocatalytic function. So the Takumi tried reducing the temperature to about 800 degrees, which is half the usual temperature. But this caused the spraying force to become too weak, and the photocatalyst peeled off easily. It took the Takumi 10 years to develop a thermal spraying device specifically for the photocatalyst agent. Here it is. By adjusting the fuel gas and other factors, he found a way to maintain the spraying force even at a temperature of around 800 degrees. As a result, the photocatalyst remained intact, adhered well to the tile surface, and no longer peeled off easily. We asked him how he plans to expand the product further.
The product can help prevent hospital infections. So I want to introduce it to hospitals, schools, and other places.
Do you have any big hopes or dreams?
I want the product to be used in outer space. For example, in space stations, where conditions aren't the best.
Special method for converting bamboo into bioplastic. Unlike commercial plastics, which are usually coated with an antibacterial substance, plant-based plastics are naturally antibacterial and also have the ability to prevent mold from forming.